Hey everyone, thanks for watching this video here. Thanks for clicking play. One thing that I've been kind of promising and teasing throughout this whole week is where does this x is equal to negative b divided by 2a equation to calculate the axis of symmetry and thus the x coordinate of the vertex come from? Everything doesn't just appear magically. Everything in mathematics has a reason and logic. And I'd like to explain that logic to you right here, right now in this video. And to start off this conversation, I read this on Reddit, a great website, a couple years back, and I wanted to share it with you and get your thoughts on it. It says, I'm taking a course on basic conic sections, and one of the ones we are discussing is of a parabola of the form that, and that's of course is standard form of a quadratic, and that's how you graph a parabola using that. And my teacher gave me the formula x is equal to negative b divided by 2a. That's the one that we have been using as well as the x coordinate of the vertex, which it is. I asked her why, and she told me not to tell her how to do her job. What are your thoughts on that? I mean, imagine you ask a question of a teacher explaining for something, and you want more explanation or something is unclear, and they say, shut up and don't tell me how to do my job. How would that sit with you? For me, that wouldn't sit well at all. I find that not only to be rude, a very rude response, but also extremely unsettling. I mean, everything in mathematics has a reason, and it's important that we know those reasons so we can better get a full understanding of what it is and how it's used. And so it continues, my smart friend mumbled something about it involving calculus. I've always found him a rather bit odd fellow, and I doubt I'd be able to understand a solution involving calculus because I have no background in it, as many of you as well don't have a background in calculus. If you use something you know from calculus, explain it to someone who has no background in it, because I sure don't. Is there purely an algebraic or a geometrical, yet elegant derivation of the x-coordinate of a parabola of the above form? Yes, there is, and I'd like to share it with you. It's actually elegant, and it requires zero calculus to understand it. And so to understand it, let's start by looking at these three already graphed parabolas in relation to their axes of symmetry. So, okay, we can clearly see, and we discovered in class, that the axis of symmetry literally cuts the parabola into two mirrored halves. All right, and I want you to think of that axis of symmetry as a mirror. What's on the left reflects the right, and what's on the right reflects the left. But let's take 2 points on the parabola, one on the left, one on the side, and that are both kind of horizontally aligned. Like, for example, we could just choose right here, this point right there, and this point right here. And then in this middle one, we could choose, this point right here, and this point right here. Now, this, of course, will work with any two horizontally aligned points. And let's choose, this one right here, and this one right here of the third one. Now, one thing that we know is that the axis of symmetry cuts it directly in half. So if I were to say the distance from, if I were to ask the distance from here, from that blue point on the left, right to the axis of symmetry, and the distance from the axis of symmetry to the other blue point on the right, what do you notice about those distances? Here, I'll do it again for this one. The distance from here to here on the left, and the distance from here to here on the right. The distance from here to here on the left, and the distance from here to here on the right. What do we notice about those distances? Keep in mind, these parabolas have symmetry. The axis of symmetry cuts it directly in half. And what do you think? I mean, we don't know specifically how long those are. We can't say like 2 units or 3 units or 5 units or... No, we don't know. But how do they relate to each other? Very good. That's right. This distance and this distance, they're equal in length. They're both 3 units, they're both 5 units, they're both 9 units, they're both 10 units. Who knows? We don't know. But they're both equal in length. And so the distance from the axis of symmetry to any point on the parabola is the same as the distance from the axis of symmetry to the kind of other mirrored, partnered point on the other side of the parabola. And this works anywhere you are on the parabola, as long as the 2 points are kind of mirrored partners of each other, called aligned horizontally. And because of that, we're going to use this to our advantage. Now, that being said, here, once again, is the equation in standard form of any quadratic. Now, remember, a quadratic is a polynomial of degree 2. And we know this is a quadratic because, boom, there's that little exponent to the second power. And the axis of symmetry equation is negative b divided by 2a. All right, so where does that come from? Well, here's the thing, and we've noticed this, is that this third constant, this third term c, it doesn't affect the axis of symmetry at all. I mean, you'll even notice in the axis of symmetry equation, c does not appear because it doesn't affect the axis of symmetry and thus does not affect the vertex. So what we're going to do is we're just going to kind of get rid of that. And we're just going to work with ax squared plus bx because, like I said, c does not affect where the axis of symmetry is. Only a and b do. So we only really need to work with that. So think of c as 0, c is 8, c is 9, c is a billion, c is negative 16. Doesn't matter. Get rid of it because it doesn't affect where the axis of symmetry is for any parabola. Okay, so therefore what are we going to do now? Well, I want us to remind ourselves of something here, and that's how to calculate the x-intercept and the y-intercept. You might recall that to calculate the x-intercept, y has to be 0. That's the only way that the point will be on the x-axis, if the y-coordinate is 0. And just vice versa for the y-intercept. To calculate the y-intercept, x has to be 0, because that's the only way that the point's going to lie directly on the y-axis if the x-coordinate is 0. But what we want to talk about today is not the y-intercept. No. I want to talk about the x-intercept. Let's calculate the x-intercepts for this general parabola. All right, now to calculate the x-intercept, as we just said, y has to be 0. So let's get rid of y. Let's replace it with 0. I mean, that's how we calculate the x-intercept, isn't it? Y has to be 0. So let's replace y with 0. You might recall doing that in 7th grade. If anyone needs review on x and y intercepts, please let me know. Happy to help you outside of class. And where are we going to go from here? Well, we're going to go back to what we've kind of known to do in our previous unit, and we're going to factor. Oh yes, we're going to factor ax squared plus bx. And remember, the first thing you got to ask yourself, does this ax squared plus bx, does it have, that's right, a greatest common factor? So think about that. Does it have a greatest common factor? Well, between a and b, well, there's no greatest common factor there. Those are just arbitrary a's and b's. But between x squared and x, that's right, a single x can be factored out. So what we're left with is ax plus b. Because remember, if you were to distribute that x back in there, you'd get ax squared plus bx, in other words, where we started. And don't forget the whole thing is still equal to 0. And because it's equal to 0 and we are solving this equation, you might recall the way we solve them is by using something called the zero product property. In other words, anything times 0 is 0. And so we have our two factors here, x and ax plus b. Ax plus b can't be factored any further, and certainly x cannot be factored any further. So what we're going to do now is we are going to, as we've done before, take each factor, either x is equal to 0, or the other factor, ax plus b, is equal to 0. Because remember, with the zero product property, if you're multiplying two things together, like we are right now, x times ax plus b, one of those factors has to be 0 itself in order for the whole thing to be equal to 0. So we have to kind of calculate for both cases, in which either x is 0 or ax plus b is equal to 0. Which means we have two, that's right, two x-intercepts. One of them is x is equal to 0. There's nothing more we can really do there. We'll plot that in just a moment. But ax plus b is equal to 0? I think we could still solve for x there. I think we know how to do that. We're going to subtract b from both sides because we want to get x alone. It's got a b behind it. It's got an a in front of it. And so we're left with ax is equal to 0 minus b, careful, negative b. And then we're going to divide both sides by a. Those a's will cancel out to become the number 1. So it's like saying 1x. But isn't 1x just nothing more than just an x? Which is equal to negative b divided by a. We don't know what b and a are, so therefore we have to leave it as negative b divided by a. All right, good. So now we technically have two very, very interesting x-intercepts, 0 and negative b divided by a. Now again, like we said, we don't know where or specifically what number negative b divided by a is, so we can just kind of, I don't know, guess it. But we do know that x is equal to 0, so here is one particular x-intercept. That's the one x is equal to 0. Boom, right there. And the other x-intercept, negative b divided by a, let's just put it somewhere over here. We don't know specifically what number it is. So let's say that's the other x-intercept, negative b divided by a. So let's label that. That's 0, and that's negative b divided by a. Those are our x-intercepts. And again, these are just arbitrary for now. Okay, but here's the thing. If we look at the equation for the axis of symmetry, it's negative b divided by 2a. And we're kind of there with that second x-intercept. It's negative b divided by a, so where the heck does this little 2 come from? Ah, that's another interesting question. It comes from the fact that what we were discussing earlier. So if these are the x-intercepts, and those are 2 points on the parabola, and again, if you want to kind of visualize the parabola kind of going like that, again, that's just a sketch. And if you want to picture the axis of symmetry guy going directly through it like that, what did we say earlier about any two horizontally aligned kind of mirrored partners? Well, we said the distance from one point to the x-axis, the axis of symmetry, and the distance to the other point to the axis of symmetry, those are equal in length. Those are equal in length. In other words, what we're doing here is we're taking the distance from one point to its kind of mirrored partner on the other side. And if the axis of symmetry is directly between those two, literally halfway between those two, I'm going to say that again. The axis of symmetry is literally halfway between those 2 points. Well, then we know that this distance right here from negative b divided by a to 0 is whatever this distance is divided by 2. That's right, divided by 2. Okay, so how does that help us? Well, all right, well, let's say we said 4 is here and 8 is here, and what's the halfway point? Well, between 4 and 8, that's, of course, 4 units between 4 and 8. And the halfway point would be, 4 divided by 2, which would be, of course, 2. So that's 2 units between each of those. So in other words, the halfway point would be right here. 2 units away from 4, 2 units away from 8. So if we want to find the halfway point between any 2 points that are horizontally aligned, we divide it by 2. So what's the distance between 0 to negative b divided by a? Well, that would be negative b divided by a, right? From 0 to 6 is 6 units. From 0 to 4 is 4 units. From 0 to negative 7 is negative 7 units. From 0 to negative b divided by a, well, that distance is literally negative b divided by a. But we want the halfway point. We want where is this halfway point in between. So like we just said, to find that halfway point, we divide by 2. So let's take the distance, negative b divided by a, and let's divide it by 2. Because that'll give us the halfway point. All right, well, as we know, negative b divided by a divided by 2 is like saying that. If I kind of wrote it the old-fashioned way using that division symbol, the line with the 2 dots, means the same thing. And as we all know, to divide by 2 for a fraction means to multiply by the reciprocal. And if we think of 2 as 2 over 1, and we multiply by 1 over 2, right? Dividing by 2 is the same as multiplying as 1/2, 1 over 2. And we just use the multiplication that we know to do for a while. We've got negative b times 1, which is negative b, because remember, to multiply 2 fractions, you multiply the numerators and multiply the denominator. So negative b is the numerator, and a times 2, a better way of saying that, is 2a. And so the halfway distance between any 2 horizontally aligned points on a parabola is negative b divided by 2a, which is the formula for the axis of symmetry. Because remember, the axis of symmetry is halfway between any 2 mirrored partnered points on the parabola. So we're just taking the entire distance between 2 points mirrored on the parabola and dividing it by 2 to get that halfway point where the axis of symmetry directly lies. That's why it's negative b divided by 2a. I hope that helped. If you need more information about that, feel free to reach out to me. But we didn't need any calculus to determine that. We just needed to know that the halfway point we divided by 2. All right, thanks for listening to this. All right, you're probably watching this through YouTube, so, I gotta say this at the end of the video. Be sure to like, comment, and subscribe. Click that little bell for Okay, actually, don't do any of that because this is all about math. Thanks, everyone. Take care.